Welcome to Math 104, Chapter 1.1, where we talk about functions and models. So what is a function? We might hear that word quite often in this class, and maybe you've heard it from previous math classes and still have no idea what the takeaway is, even after a definition is given. So this one is from our textbook. It just says a function is a relation for which each value from the set where the first component of the ordered pair is associated with exactly one value from the second. That is one of the worst sentences possible when coming up with a definition for a function. All it's trying to say is that let me redo that. Every x value has one y value. Or even better, x's do not repeat. So one of those two sentences should resonate just a little bit. So either every x value has one y value. And x values in this case, these are called your input values. And y values are called your output values. Or x's do not repeat. So your x values in this case, your input values should only have a y value. So for each coordinate, we're looking for your x values not to have any sort of repeat. Now it says data in any real world information collected is in numerical form, such as the below. We have Fahrenheit and Celsius. Is the function y or y not, and does this model actually make sense? Well, first off, let's start off with, is it a function? Do your x values repeat? Well, x values in this format, if we're confused as to which one is x and which one is y, we're going to just say this one, Fahrenheit is a function of Celsius. So Celsius is x and Fahrenheit is y. And we can see that along here too. Our template is also given for your graphical terms, or you can see that along the x is your Celsius and along the y is your Fahrenheit. So now looking at your x values, are there any sort of repeated x values? Well, we go from -20, -10, -5, 0, 25, 50, and 100. None of those at any point in time have repeated. So it is a function. So yes, I should put that up here. Yes, a function. So now, does this data make sense? Now, you may or may not know a little bit about Celsius or its conversion to Fahrenheit, but one of these conversions should make sense. It's just saying that -20 degrees Celsius is the same as 40 or -4 Fahrenheit, or -10 Celsius is the same as 14 degrees Fahrenheit. Now, looking at each conversion, is there one that perhaps should resonate from previous courses or just kind of everyday life? Well, hopefully we know that 0 degrees Celsius is the same as 32 degrees Celsius, where it is now freezing. Celsius is nice because it's either 0 is the freezing point, and then above that is non-freezing, and below is considered below freezing, right? So this data does in fact make sense. Therefore, it is useful information. We can grab data and make inferences from it and be correct. Now, even better about this form of data is that each of the above is an element and therefore is not continuous in an interval. We were working with intervals in our previous section where we said, okay, well, x is greater than 1. Therefore, we knew, x is greater than, greater than 1 could be an example. So therefore, we're working with an interval of anything that's close as possible to 1 and then above it. And that could signify 2, 3, 4, 5, and it continues all the way up to infinity. Whereas our data here, we only have 1, 2, 3, 4, 5, 6, 7 points located on our graph. And they're all segmented. They're all elements. It is not a continuous solid line. Instead, they are little points on here. So that's what we mean by elements. Now, when it contains elements, our domain, your x values, for your domain are all of your input values, meaning that we get to choose all of your x values for your domain. So all of your Celsius coordinates. So -20, -10, -5, 0, 25, 50, and 100 are all values for your x on that particular data function. Now let's see if you can do again the range, but instead of your x values, these are your y values. These are your output ranges. Output values. So instead of all of your x values, we now get to list all of your y values. So when just data is given as a chart and there's no interval, there's no solid line, instead it's just kind of point by point, we can just list out each point, but as it's either the x counterpart or the y counterpart. Now, perhaps they've also given us some function to work with. So it says, given the function f of x is equal to 9/5 c plus 32. And knowing that normal temperature is normal temperature, I should say, of a human is 98.6 degrees Fahrenheit. This is indicated normal for Celsius. They're going to say is 37 degrees Celsius. Is this accurate? Do we know that to be true? Well, they're telling us, right, that 98.6 degrees is your Fahrenheit, and they've also told us a formula for it. They also tell us that your Celsius that resonates with 98.6 degrees Fahrenheit is 37 degrees Celsius. So they have given us a Celsius to work with. And in order to determine if they're accurate, we should get out 98.6 degrees. So let's go ahead and work that in and see, is it in fact true? So instead of C, we're going to work in your 37 degrees, and we're going to put that right into a calculator. We're going to be using Desmos today. So we have 9/5. Oops. Uh-oh. There we go. 9/5. You can see how often I work with Desmos sometimes if it's been a little bit. 37 plus 32. So we get 98.6. Is that the value we are trying to match? Yes. So it came out to be 98.6. So is this an accurate function to represent your data? Again, yes, it is. It is accurate. Now, when it comes to functions, there are specific tests that we can do when it's in a graphical form. One being the vertical line test. Which says when a vertical line is drawn to determine if y is a function of x, no two distinct points on the graph will have the same x coordinate. Again, this is a very wordy way to say, okay, we are going to draw any vertical line on your graph. We can do it anywhere on your graph, doesn't matter. And because we know that by definition of a function that every x has its own y value, or x's do not repeat, the vertical line test will show us, do we have repeating x's? Well, somewhere on your graph here, and maybe I did too much for these tiny graphs, somewhere here on your graph, we're going to be touching the line along with your graph. And if it touches once, let's say at this point we have the coordinate, looks like -2, 1, 2, 3, 4, 5, -2, 5. Is there another location where we could have a -2? No. Either above or below this line, it looks like the graph is going away from your line. So at no point will -2 repeat. And that could be at anywhere on your graph that you draw this vertical line. So if it touches once, it is a function. Whereas if we were to, again, draw this line maybe a little less thick anywhere on your graph, what do you notice? Well, at this point, we can see that your x value, and let's say this is 1, 2, 3, 4, your x value has now repeated. -4, comma, let's say 1, 2, 3, 3.5, or -4 and -3.5, right? Something along those lines. You can clearly see that your x value has repeated, meaning that if your vertical line touches more than once, it is no longer a function. Let's try it one more time. Is this one a function or not? No, not a function. So it's nice and easy to see when it's graphical. And now we're going to tell down the line what to do if if we're evaluating. So evaluating functions. Given f of x is equal to 4x squared minus 2x plus 3, evaluate when x is equal to 3 and again when it's -1. So we've actually done a little bit of evaluating already, and we did so here as well. What we didn't know it was called is evaluating, where we're being told what a specific variable is equal to. We plug it in and see what comes out. Now, typically we don't know what is going to come out, which is exactly what we're going to see here. So if we know that x is equal to 3, so I want to know what happens if I plug in a 3 into my function. Now keep in mind, f of x is another way to say y. It's just an easy way to show what value is going in. So originally we had f of x is equal to 4, x squared minus 2x plus 3. Now what's going to happen is I'm going to now eliminate my x. And now that my x's are eliminated, I'm going to actually plug in 3. That's what my new x value is going to stand for. And then from here, we can plug this right into your calculator, or we can do a little bit of evaluating just using our brains. So rules of order of operations, we want to do your exponent first, or parentheses first, then exponents, then multiplication or division, whichever comes first, and then we can add and subtract. So 3 squared is equal to 9, and I'm just going to move sideways. -2 times 3 is 6, plus 3. 4 times 9 is 36, minus 3 from the subtraction. And again, one more time, subtracting, we have 33. Now this just says we put in a 3. This is your input value. And therefore, your output value is whatever came out. We got out a 33. Now this is our final product. These are actually going to be points on your graph. So we can put in a 3, and when we put it in, we get out a 33. Now let's say you guys try that one more time with -1. Now keep in mind, you don't have to do it by hand if you don't want to. You can take the time to plug it into your graphing calculators. So now we know when x is equal to -1, we are going to take the same formula, and I'm going to leave gaps everywhere the x value came up. I'm going to insert this time, instead of a 3, it's now a -1. Again, with the double negative here, this is really -1 times -1. So there's 2 of them, which means the negative will go away. So 4 times +1. And again, your double negative, we multiply it to 2 plus 3. So 4 plus 5, that gives us 9. So again, we have an input. We plugged in the x, and therefore our output, we get out a 9. So again, this is a point -1, 9. Now, specifically, this is a point on the graph of the function f of x is equal to 4x squared minus 2x plus 3, which is the exact graph over here. And you'll notice that those points have been exactly mapped, meaning that any x value that we choose will map to a specific y value. Now, is this graph a function? Yes, it's a function. Anywhere you draw a vertical line on here will only come up with one x value. This one's a little steep, so I can only do a few of them, but yes, it is a function. Now, when we go to evaluate with tables, we don't have a graph to work from to kind of pick out our points. We don't have an equation to work from either. Instead, they're defining all of your x and y values. Keep in mind, f of x is just another way to say your y value. So let's see if you can pause the video and try out the first 4 questions. Well, for us, when it says find f of 2, this is saying f of 2. This is just saying, okay, well, we're going to plug in a 2 for your x value. This 2 is signifying your x, meaning that we have to go along this stretch to figure out where does the 2 occur. Well, 2 occurs here, which means we now want its y counterpart to come out. That kind of signifies what we did here, but in its shorthand on the table. So you plug in a 2, you got out a -1. And we can go in the reverse. When it says f of x is equal to 5, that just means along this f of x line, where does the 5 occur? Well, it occurs right here, meaning that its x counterpart is -1. This is when x is equal to -1. Now, is this a function? So at any point in time, do you see x's repeating? No, thankfully it does not repeat. Therefore, yes, it is a function. The reason why we don't want it to repeat is that we want one value to say that this is going to occur. So next time I put in a 2, I don't want it to go to -1 and -8. I only want it to go to one of them. So I know that this value is our solution. Now D says, is 3 an input or an output? So up above here, or down below here should be 3. Well, 3 being here is your x value, therefore it's an input value. And then in this notation, f of 3, that is just exactly how we said this part, right? F of 2, when I plugged in the 2, it comes out to be the -1, which in this case is our y value. So same thing here. This is now our output value. F of 3, we plugged in the 3 into our function, into your table, and we get out a -8. That is your output value. Now let's give it a little bit of context. The table shows the values in billions of dollars of U.S. industrial shipments from 2024 to 2040. So A says if S represents the value of U.S. shipments, so S is going to signify our Y values, and X is a year, or years is for X. Is S a function of X? So they do tell us explicitly that X is equal to years, but let's say we missed that sentence, or they didn't quite define it enough for you. A tidbit is that any sort of time constraint, year, month, seconds, you name it, if it's time, it's going to be X, because X is our independent variable. You cannot cap time, you cannot limit time. It just is continuous, it's fluid. Therefore, it has to be your X value. So take a look at your X values. What do you think? Is it a function or not? Yes, it is a function. There are no repeating years. And when it says find f of 2035 and explain the meaning. Well, x being 2035, We can locate that as our year, and directly across from it, we know that your Y counterpart is 10.56. Now keep in mind, your Y counterpart represents the value of US shipments in billions of dollars. So how can you pair these two ideas together to create a sentence? Give it meaning. Well, we can start off something by saying, in the year 2035, and because we haven't reached the year 2035, we don't know that this is actually true. It is an estimate, it is a prediction. It is predicted that the US industrial shipment will produce or will make 10.56 billion dollars. We always want to have some sort of units. So I know, oh, they're not just going to make $10 or nearly $11. It's going to be $10 billion and some. So now let's have you guys try it again with C. It says find X if f of X, again, Y, is equal to 8.84. What does this mean? So where on your Y coordinate, your value in billions of dollars is 8.84 appearing? Well, that would be right here. And its counterpart for the year is 2023. So again, what does it mean? Can you bring any sort of context? Well, we know that the X value being 2023 is your year. Now, 2023 has passed, so we can kind of tell that, okay, this has happened, or at least come close to it. Perhaps it is an accurate model and we have achieved that. We could say in the year 2023, the US industrial shipment produced $8.84 billion. And that is just about everything we can do for now with your functions, evaluating them, determining whether or not they are functions.